Biology is a lot about chemistry, and we'll see that throughout the year. We'll start with a couple of basic ideas. Again, I think a lot of this is going to be review. I think you all are aware that matter, all the stuff out there that has mass and occupies space, matter is composed of atoms, the building blocks of all matter. And the old models of atoms, which make it look like there's this glob in the middle and a bunch of organized electrons orbiting around like planets around a star, like in our solar system. That old model we know is inaccurate, and a better model, the more modern model of an atom, is one with an electron cloud surrounding the nucleus. And the nucleus, if it was drawn to size in this picture, you wouldn't be able to see it because the nucleus is tiny in size compared to the volume taken up by the electron cloud. But almost all the mass of an atom is in the nucleus, all the weight. The protons and the neutrons that are in the nucleus are the heavy parts of atoms. So the nucleus is in the center, electron cloud surrounding, and in this electron cloud diagram, the darker shading shows where the two electrons that live in this electron cloud are more likely to be. We cannot say with any confidence where an electron will be at any given time. They are very slippery little devils. But we can say where they're more likely to be at any given time. And that's what is shown by the shading in this electron cloud model. The particles that make up atoms are protons, neutrons, and electrons, positively charged protons, negatively charged electrons, and the neutrons, which are neutral. In a helium atom, the typical helium atom, there are variations on helium, but all helium atoms have two protons. That's what makes helium helium. It has two protons in the nucleus. A typical helium atom also has two neutrons in the nucleus and will have two electrons orbiting in the electron cloud near the nucleus. Element is a pure substance. These are the substances that make up all other types of substances in the universe. There are about 90 naturally occurring elements in the universe, and these are the substances we find on a periodic table. And we'll take a look at a periodic table, a simplified one, in just a minute. The elements all have symbols that have one or two letters to represent them. The symbol for carbon is C, and just to confuse you, lots of the elements are based on Latin or Greek names, so sometimes the symbols don't make much sense for the English word. So, for example, sodium is Na. Just a few elements make up the majority of the bodies of living things, whether that be plant, animal, fungus, or prokaryote. Those elements that make up most of our bodies are carbon, hydrogen, and oxygen first and foremost, nitrogen, phosphorus, and sulfur. And then there are a few other elements, as you can see on this simplified periodic table, shaded in the violet color, that are also important components of living things, but they exist only in tiny amounts inside those living things. The definition for atomic number is also on this slide. I mentioned a moment ago that helium is helium because it has two protons. Carbon is carbon because it's got 6. If an atom has 7 protons, that would make it nitrogen next door to carbon. And if an atom has 8 protons, that would make it oxygen next door to nitrogen. Chemical compounds are when atoms of more than one type of element combine with each other in definite proportions. And a couple of important compounds for life are shown on this diagram. On the left is our friend, the water molecule, that we'll learn lots about very soon. And on the right, that is a sugar molecule, specifically a glucose molecule. And if you count up all the atoms there, it has 6 carbons, 12 hydrogens, and 6 oxygens. That would make up the chemical formula for glucose, C6H12O6. For compounds that are made up of molecules like water and glucose and urea, the formula of that compound will tell you how many atoms make up each molecule of that substance. So water molecule has 2 hydrogen atoms and 1 oxygen atom, H2O. This glucose molecule, a single smallest piece of glucose you can get, 6 carbons, 12 hydrogens, 6 oxygens. All right, chemical bonds are what hold compounds together, and there are 2 types of chemical bonds, covalent and ionic. But in both of those cases, the bonding is because there are interactions between atoms with the electrons on the outermost part of the atom. The electrons that are on the far outside of an atom are sort of the face of the atom. They are like what determines the characteristics of the atom. Not surprisingly, they're what's on the outside. They're what interacts with other atoms as they are bouncing around the universe. Those valence electrons are important for determining the properties of a particular type of atom. And they are the electrons that are involved in the bonding between atoms. So you see the water molecule again here. The bonds that are forming between the hydrogen and the oxygen atom in a water molecule are because of the attractions between those atoms and the valence electrons of the other atom. So ionic bonds happen when atoms give up or gain electrons and become positive or negatively charged particles. And covalent bonds form between atoms like the water molecule that are sharing electrons. So there's a covalent bond here between the hydrogen and the oxygen. They're sharing that pair of electrons. The nucleus of the hydrogen and the nucleus of the oxygen are both mutually attracted to those shared electrons, and that's what keeps them stuck together. Same with that bond between the other hydrogen and the oxygen. With ionic bonds, again, an electron is transferred from one atom to another, so you wind up with one atom that has gained an electron, and therefore, since it's gained a negative charge, it's negatively charged. The atom that loses an electron now has a positive charge because it has more positively charged protons in the nucleus than electrons out in the electron cloud. And now there is an attraction because we have a positive and a negative charge. That is a tremendously important idea in chemistry, that positive and negative charges, opposite charges, attract each other. So back to our water molecule and a covalent bond. This is when atoms are sharing electrons. And here you see before the sharing takes place, each of the hydrogen atoms has its single electron. Hydrogen is element number 1, 1 proton, 1 electron. And it can form these covalent bonds with a single oxygen atom, and the sharing of now what is a pair of electrons, 1 from the oxygen, 1 from each hydrogen, will form those covalent bonds, and mutual attractions between those atoms, nuclei, and their shared electrons is the glue that holds them together. Okay, so when atoms join by covalent bonding, we have a structure called a molecule. And I touched on this a moment ago, a really hugely important idea in chemistry, and therefore a hugely important idea in biology, um, is this attraction between opposite charged particles. Um, Opposite charged particles, positive and negative, are attracted to each other. Like charged particles, two positives or two negatives, repel each other. And those attractions and repulsions are absolutely essential to what goes on inside of a living thing. And we will run across this again and again and again this year. All right, that's it for the first little video for our class. We'll see you soon.